So in this chemical reaction, we have potassium dichromate reacting with hydrochloric acid and producing potassium chloride along with chromium 3 chloride, chlorine gas, and water. What's different about this chemical reaction is that we only have the polyatomic ion of potassium dichromate showing up in the reactant side. It's not showing up in the product side. So therefore, I'm going to break this into potassium, chromium, and oxygen. Let's start out by determining how many atoms we have. We have 2 atoms of potassium, 2 for chromium, 7 for oxygen, 1 for hydrogen, 1 for chlorine. On the product side, we have 1 potassium, we have 1 chromium, we have 1 oxygen, we have 2 hydrogens, and we have a total of 1 plus 3 gives me 4, 4 plus 2 gives me 6 chlorines. Next, we need to identify the loner, and that is the one that is not part of a compound, and the only loner in this chemical equation would be chlorine. So I'm going to write it in here. We want to end with the loner if possible. Now we need to identify the 1:1 ratio, also known as the pair element, and that is the one that appears one time in the reactant side and one time in the product side, and it does not matter if the subscripts are different. So potassium 1 time in the reactant side, 1 time in the product side. Chromium 1 time in the reactant side and 1 time in the product side. Oxygen, hydrogen, and then chlorine. It appears 1 time in the reactant side and it appears 1, 2, and 3 times in the product side. So it's a no. Now we need to start with the largest 1:1 ratio, and this would be the one that has the largest subscript. So from the ones that we put the check mark, which one has the largest subscript? That is going to be the oxygen in the reactant side. So I have 7 oxygens and I have 1 oxygen on the product side. It's much easier to change this to a 7. So before I can change this to a 7, I'm going to lock in this product with a coefficient of 1. 1 times 7 gives me 7. So I'm going to come over here to the product side and I'm going to write a 7. I now have 7 oxygens. So I'm going to change this to a 7. So our oxygens are balanced. Now, I'm not going to continue here yet. I'm going to continue here because this 7 is going to produce a bigger change. So 7 times 2 gives me 14 hydrogens. So if I have 14 hydrogens here, I need to have 14 hydrogens in the reactant side. So I'm going to write a 14. And at this point, we have the coefficients that we need in the reactant side. So now we'll come back over here and see what we have. So we have 1 times 2 gives me 2 potassium. So I need 2 potassium. So I'm going to write a 2 in here. I'm going to erase that. And now I come back over here. I have 1 times 2 gives me 2 chromium. So I need to have 2 chromiums. So we have the chromiums that are also balanced. And we already talked about the oxygens. Now, for our hydrogens, we have 14 of them. And we talked about that already. So the only ones that are left are our chlorines. We have a total of 14 chlorines. So I also need to have 14 over here. But let's find out how many we have so far. So we have 2. And then 2 times 3 gives me 6. So I have a total of 8 so far. But notice that I'm not including the ones from here yet. So I'm going to say 8 based on here. 8 plus what number will give me a total of 14. So 8 plus what number will give me 14? So 8 plus 6 gives me 14. I'm not saying that I'm going to write a 6 over here, but I need to have a total of 6 atoms. So if I write a coefficient of 3, 3 times 2 is 6. So at that point, everything is balanced. So you should have 1, 14, 2, 2, 3, and 7.